Hi, my name is Adam. In our survey area project, we collaborated with students in Kenya to help identify common waterborne diseases in their surrounding areas. We researched the diseases and filtration devices and solutions to help solve the problem of contaminated water in their community.
My name's Elise. I go to Rosa High School and I'm a senior.
I'm Adam. I'm 17 years old. I'm a senior.
I'm John Dale. I live in Seattle, Washington. I attend Roosevelt High School.
I'm Fiona. I'm from Germany, but I'm an exchange student here.
I'm Marimgoy and this is my partner, Kulthum Mohammed. Yeah, we are outside our DH, our lovely DH, and we are with the third person over there. She's coming right now. So come! Yeah, that's how we're supposed to do it.
Hi, my name is Makatalu and I'm also doing a project on Siberia, and we'll take you through our school and show you what we do in our school and what is in our school. Welcome. Hope you enjoy everything.
Yahoo!
Here in Seattle it rains a lot and we have mountains on either side, so it comes down and we have a lot of rivers and lakes, and so we have a lot of water here that we can...
Okay, so here, this is where the collection of water begins. It's being collected that hill over there, and then it flows to that point. It flows, then taken this side up to now the settling tank. Now the members of the community ensure that the water is well distributed, it's well taken care of, so that you can prevent the wastage of water. And
we use water for cleaning ourselves almost every morning.
We have enough water. Yeah, this is where we usually wash our plates from after taking our lunch. There are tanks with the salt water. They are going to be pumped in our tap so that we can use them later. Because you can't get water from the other areas. So this water is for the dome, the Susu dome. They use this tank to get their water and it up. These are our
latrines, toilets.
These are our latrines. We had a shortage of water, so we had to go to the river. This is the path we use to go to the river. We get our water from down there.
So we are outside our school compound. We are here to show you how we get our water in the school like the Bura Girls High School. First of all, our water comes from the hill, then it flows to the stream. There is water which is flowing in the stream. Then from there onwards, it comes to this place, this tank here, where it's translated down here. Even if there's some water, you can see entering inside the tank. There inside the tank.
And they see
So, yeah, after that, it's taken the pipe. There's a pipe which is connected into this pipe. It comes inside this pipe, it flows in the pipe, then it's pumped with by the generator, which is in this small building. It's just a small room, not much, because it's not being, so that even is being pumped here every day. So that can ensure a maximum flow of water. And then being switched on here.
In front of you here we have the school nurse, and we'd like to ask her some questions about the water in the school. And our first question is, do you treat your water before using it?
Yes, we do.
Where do you get your water from?
We get it from a river source, but it is tapped.
So what measures do you take in case your water is polluted, if it has ever been?
Yeah, it is we normally treat it with chlorine or water guard, or we use boiling method.
Okay. Are you affected with waterborne diseases?
Yes, we are. We normally get cases like typhoid, amoebiasis, intestinal worms, and also we get gastroenteritis and typhoid and dysentery at times.
How do you treat your students if they get these diseases, if they affect them?
When we discover that they have been affected by such, there are some of these diseases which we can treat in school. Like for instance, intestinal worms, we can treat them in school. And even gastroenteritis, we can treat it in school. But something like typhoid and dysentery, we refer to the nearest hospital or to the nearest dispensary.
Okay, so is it so often that they occur, or?
They occur very often. Yeah.
And have you ever experienced shortage of water?
Yeah, we do very often, because normally some of these pipes break, and once they break down, we have no any other source, but the girls have to go to the river to fetch the water themselves.
Okay, I would like to thank you so much for your cooperation and for everything. Thank you so much.
Thank you too. Welcome.
Cholera, like most waterborne diseases, is transmitted via the fecal to oral route. But 5% of humans who ingest the bacterium Vibrio cholerae will have severe cholera, which results in intense diarrhea for several hours, which results in water loss and usually death. Kenya has experienced 2 epidemics. The most severe one was in 1997, when about 1,000 people were killed, and the most recent one was in 2009, when luckily only about 500 people were killed. This shows that cholera can be ended.
Typhoid fever is caused by the bacterium Salmonella typhi. Its transmission occurs by ingestion of food or water that has been contaminated with feces of an infected person, and it looks just like any other bacteria.
Schistosomiasis is a disease caused by a parasitic worm of the schistosoma type. This disease infects over 200 million people worldwide. It is contracted by contact with contaminated water. Upon release of eggs from a host, the eggs live in snails and then are released as cercaria into the water. These cercaria enter the body through the skin, where they then make their way to the intestines and GU tract, where they can reach maturity and start releasing eggs. HEV, hepatitis E virus, is a single-stranded RNA virus that is contracted via the fecal to oral route and is an epidemic disease commonly found in East Africa and East Asia.
Giardia intestinalis is, like most waterborne parasites, contracted from water or soil that has been contaminated with fecal matter. Giardia is able to survive outside of its host due to its protective shell. Ascaris lumbricoides, or the common roundworm, is the largest parasitic worm to use humans as a host, getting up to 49 centimeters long. It has also contracted from water, food, and soil that has been contaminated by its eggs.
There are 3 types of water filtration that I'm going to discuss: chemical, slow sand, and membrane filtration. Chemical includes the simplest version, which is solar filtration. Simply filling a clear plastic bottle with water and then placing it in the sun for several hours can kill the bacteria in it by UV rays. It's not the most effective or the most efficient, but it is the simplest and most cost-effective. The second chemical method is chlorination, which is extremely effective and quite cheap. The third method of chemical filtration is flocculation and disinfection. A flocculant causes sedimentation, so the turbidity and the dirt particles in the water cluster together and fall to the bottom so they can be filtered out. And a flocculant disinfectant is combined with a flocculant is usually combined with a disinfectant to kill the bacteria, just as chlorine would. Slow sand filtration is very simple and has been around for many, many years. It simply involves pouring water on top of a column of sand and allowing it to filter through by gravity. The bacteria and other pathogens are trapped within the sand particles. Extremely effective. There's a variation of the slow sand called the biosand filter, which actually uses pathogens against themselves to attack each other and further reduce the pathogen level in the contaminated water. Membrane filtration is perhaps the most high-tech of all the filtration methods. It involves membranes with very, very small pores poked into them, just microns across, which prevent bacteria, viruses, and other pathogens from going through, but allow water to pass through. These can be designed to combat specific pathogens when the size of them is known, so that membranes can be designed with the exact correct size to filter out that specific pathogen, or they can be made extremely small, about 0.02 microns across, to exclude almost every single virus, bacteria, and other pathogen. The water crisis in the developing world is a crucial problem, but through the filtration techniques we laid out, it is possible to solve it. It'll take a lot of collaboration, not just in Kenyan communities, but with the global community as a whole to solve this crisis. We hope that this documentary can shine some light on the problem of the water crisis in the world, and that we've provided a light for help solving these problems with our suggested solutions. We've sent a copy of the potential solutions to the Bura Girls High School in hopes that they will examine them and hopefully improve their water quality in the future. Thanks for watching.